ಆತ್ಮೀಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಬೆಳಗಿನ ಶುಭೋದಯ. ನಾನು ನಿಮ್ಮ ಗಣಿತ ಶಿಕ್ಷಕ ಆರ್ ಮಂಜುನಾಥ್. ಈಗ ನಾವು ಏಕಗಣಿತದ ಭಾಗವಾಗಿರ್ತಕ್ಕಂತಹ ಮೇಲ್ಮೈ ವಿಸ್ತೀರ್ಣಗಳು ಮತ್ತು ಘನಫಲಗಳು ಈ ಒಂದು ಘಟಕದ ಬಗ್ಗೆ ಅಭ್ಯಾಸವನ್ನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಈಗಾಗಲೇ ನಾವು ಘನಾಕೃತಿಗಳಾಗಿರ್ತಕ್ಕಂಥ ಆಯತ, ವರ್ಗ, ಸಿಲಿಂಡರ್, ಶಂಕು ಮತ್ತು ಗೋಳ ಮತ್ತು ಅರ್ಧಗೋಳ ಇವುಗಳ ಪಾರ್ಶ್ವ ಮತ್ತು ಪೂರ್ಣ ಮೇಲ್ಮೈ ವಿಸ್ತೀರ್ಣಗಳ ಬಗ್ಗೆ ಆ ಸೂತ್ರಗಳೊಂದಿಗೆ ಪ್ರಾಬ್ಲಮನ್ನು ಬಿಡಿಸ್ತಕ್ಕಂಥದ್ದನ್ನು ಕಲ್ತ್ವಿ. ಹೀಗೇ ನಾವು ಒಂದು ವಿಡಿಯೋ ಅರ್ಥ ಆಗೋದಕ್ಕೆ ಇದು ಸರ್ಫೇಸ್ ಏರಿಯಾ ಮತ್ತು ವಾಲ್ಯೂಮ್ ಅಂತ ಕರಿತೀವಿ. ಕ್ಯೂಬಾಯ್ಡು, ಕ್ಯೂಬ್ ಅಂತಂದರೆ ವರ್ಗ, ಕ್ಯೂಬಾಯ್ಡ್ ಅಂದರೆ ಆಯತಘನ. ಈ ರೀತಿಯಾಗಿರ್ತಕ್ಕಂಥ ಇವುಗಳಿಗೆ ಸೂತ್ರವನ್ನು ಯಾವ ರೀತಿ ಕಂಡುಹಿಡಿಬೇಕಂತಕ್ಕಂಥದ್ದನ್ನು ಒಂದು ಚಿಕ್ಕ ವಿಡಿಯೋದ ಮುಖಾಂತರ ನೋಡ್ತಾ ಬರೋಣ. ವಿದ್ಯಾರ್ಥಿಗಳು ಗಮನಿಸ್ತಾ ಬರ್ರಿ.
A cuboid is simply a box like this. It is three-dimensional as it does not occupy a part of just one plane. Three things define a cuboid: length, its breadth, and its height. This is a cuboid. What will be its surface area? As the name suggests, it will be the total area of all its surfaces. A cuboid has 6 surfaces in all, one at the front and one at the back. Their areas will be equal as it has a uniform cross-section. Area of each will be L times H, and the total area of both together will be 2LH. Similarly, the sum of the areas of the faces at the top and bottom together will be 2LB, and the sum of the areas of the faces on the right and left will be 2BH. That's the total surface area of a cuboid. Taking the factor 2 common, we can write it as twice LH plus LB plus BH. What is its lateral surface area then? The word lateral simply means side. This is the sum of the areas of the faces on the side, not the faces at the top or the bottom. So it will just be twice LH plus BH. We ignored 2LB as they are the areas of the top and bottom surfaces. So these are the two types of surface areas we had to understand. The last concept is that of its volume. The volume of a cuboid is simply the product of its length, its breadth, and its height, LBH. To be more specific, it is the area of its base times its height. Knowing stuff about cuboids also helps us understand its special case, the case of a cube. It looks similar to a cuboid. It has length, breadth, and height, with the only difference being that all three are equal. Let's say each is equal to S units. Think about it. If each of the sides are equal, then each face will be a square. The area of each face will be S squared. As there are 6 faces, the total surface area will be 6S squared. What will be the lateral surface area and the volume then? As it has 4 faces on the side, its lateral surface area will be 4S squared. As L, B, and H are all equal to S, the volume of a cube will be side cubed. In the next session, we will look at the volume and surface area of a cylinder. surface and another circle. This is a cylinder, a right circular cylinder to be precise. Every cylinder has a central axis which passes through the centers of the two circles. The areas of the two circles are equal. That's because the cylinder we consider has a uniform cross-section. This tells us that the radii of the two circles will be equal. In a right circular cylinder, the distance between the two centers of the circles is its height. Let's call it h. So how do we find the total surface area of the cylinder? It will be the sum of areas of the two circles and the area of the curved surface. As the radius is r, the area of each circle will be pi r squared. So the sum of the areas of both the circles will be pi r squared plus pi r squared. But what is the area of the curved surface? This is interesting. The curved surface when opened up will look like a rectangle. And what will be the length and the breadth of this rectangle? The breadth is easy. It will be the height of the cylinder. But what about the length? Yes, the length of the rectangle will be the circumference of the circle. It will be 2 pi r. It was easy. All we did was open this curved surface up. Anyway, these two together add up to 2 pi r squared, and the area of this rectangle will be 2 pi r h. That's it. This is the total surface area of a cylinder with radius of the base r and height h. As 2 pi r is common to both the terms, we can write it as 2 pi r times r plus h. That's the total surface area. What is this blue part then? It's called the curved surface area of the cylinder, 2 pi r h. And finally, we come to the volume of a cylinder. It equals the area of its base times its height. As the base is circular, its area will be pi r squared and its height is h. That's the volume of a cylinder, pi r squared h. You don't have to memorize any of this. You can easily derive the total surface area, and for the volume, you just need to know that it is the area of its base or its cross section times its height. Today, we look at the surface area and the volume of a sphere. This is how we can draw a sphere. The dotted portion is what cannot be seen from the front view. And this is the center of the sphere. And let r be its radius. Don't forget, every point on the sphere is equidistant from its center. How do we define the surface area of the sphere? The surface area of the sphere equals to 4 pi r squared. A sphere has just one type of surface area. Its total surface area is its curved surface area, as it does not have any flat surfaces. And the volume of the sphere is given as 4 by 3 pi r cubed. At the moment, we do not need to know how we arrived at the formulae, but we will cover this topic for sure in one of our videos of higher grade mathematics. If we know the formulae for a sphere, we can easily derive the formulae for a hemisphere too. And what is a hemisphere? A hemisphere is half a sphere. Let's say it has a radius r. We have just cut the sphere horizontally and we are looking at the bottom part. The best way to understand the hemisphere is by looking at the Earth. The equator divides the Earth into two hemispheres, the northern hemisphere and the southern hemisphere. If we split the Earth at the equator, we get two hemispheres like these. Okay, great. Let's get back to our figure now. What do you notice looking at the hemisphere? The first thing you should notice is that it has a flat surface and a curved surface. This tells us that unlike the sphere, the hemisphere will have a different curved surface area and total surface area. Let's look at the curved surface area first. Looking at both the figures, we can easily say that it will be half that of the surface area of the sphere. Dividing this by 2, we get 2 pi r squared. That's the curved surface area. What about the total surface area? The total surface area will be the sum of the area of the curved surface and the area of the circle on top. We have figured the area of the curved surface to be 2 pi r squared. The area of the circle on top will be pi r squared. Adding these two, we get 3 pi r squared. So the curved surface area is 2 pi r squared and the total surface area is 3 pi r squared. What about its volume? Again, the volume of the hemisphere will be exactly half that of the volume of the sphere. Dividing this by 2, we get 2 by 3 pi r cubed. We have a right circular cone with a shaded base, and we will try to derive a formula for the surface area of a cone. Let us name the points O, A, B. Points A and B are marked on the circumference such that AB forms a diameter. Let L be the slant height and H be the perpendicular height. And let R be the radius of the circular base. First, let us consider the circular base. The radius of the circular base is r, so its area will be pi r squared. Next, we need to find the area of the curved surface. And we have seen that when the curved surface is opened up, it looks like a sector. We also need to find the area of the sector. Let the sector be OAB. Look at the sector and the cone. What do you think is the measure of these two lengths? OA and OB will equal the slant height, which is L. Here's another interesting question. What will be the length of arc AB? This is an arc as we know that a sector is part of a circle. This arc is actually the circumference of the circular base. So the length of this arc will be 2 pi r. A sector is also defined by the angle it subtends at the center. Let us call it theta. Now we are ready to find the area of the sector. And it gets even more interesting. There is another way in which we can find the length of the arc AB. Let's zoom out to look at the other way. It will equal theta by 360 multiplied by the circumference of the circle with radius OA and OB. What will be the circumference of the circle that is formed with this as the sector? It will be 2 pi L, since L is the radius of the circle of which this sector is a part. This tells us that the length of arc AB is a part of the circumference of the big circle that can be formed here. But the length of arc AB is also 2 pi r. That will equal theta by 360 multiplied by 2 pi L. Cancelling 2 pi out from both sides, we get r equal to theta by 360 multiplied by L. The area of this sector will be the curved surface area of this cone. The area of this sector will equal theta by 360 multiplied by the area of the circle with OA and OB as the radius. And that will be pi L squared, as L is the radius of this circle. Can we write this a bit differently? Yes, this can also be written as pi L multiplied by theta by 360 multiplied by L. We have just split pi L squared into pi L multiplied by L. But this part in brackets, as we just found out, is equal to r. So the curved surface area will be pi L multiplied by r. Let us review what we just did. We found out the length of arc AB in two different ways and equated them. And then we found out the curved surface area using the formula of a sector of a circle. And then finally substituted the value of r in this formula to eliminate theta. Now it's very simple. The total surface area of the cone will be the curved surface area plus the area of the circular base. The curved surface area, as we know, is pi LR, and the area of the base is pi r squared. Both the terms have pi r as their common factor. Taking pi r common, we write the formula as pi r multiplied by L plus r. This is the formula for the total surface area of a right circular cone. We are now going to try to understand a very important concept about circles. Look at this circle divided into two equal parts. How do we find the area of this colored part? Let's assume that the radius of this circle is r units. You are familiar with the area of a circle, and we can see that it covers half the circle. So the area will be half multiplied by pi r squared. This is the area of this circle, and we multiply it by half to find the area of this colored part. Now look at this circle, which is divided into four equal parts. What will be the area of this colored part? It will be 1 by 4 multiplied by pi r squared. Since the area of the circle is split into four equal parts, we multiply it by 1 by 4. Let's look at another part of the circle, this part. What will be the area of the colored region in this case? Without any information, we cannot find the formula for the area of this part. More importantly, what we are trying to find is the part of the area of a circle. These colored regions are called sectors. You may think of a sector as a pizza slice. A sector is covered by two radii and an arc. In the first case, these are the two radii and this is the arc. In the second case, these two are the radii and this is the arc. And in the third case, the sector is covered by these two radii and this arc. Coming back to the question, how do we find the area of this sector? The area of a sector is proportional to the angle that the arc subtends at the center. It is called the sector angle. In the first case, the sector angle is 180 degrees. Hence, the area of the sector will be 180 by 360 multiplied by pi r squared. Out of the total 360 degrees, these two radii have 180 degrees between them. This value is the same as this value as the ratio equals half. Similarly, since the sector angle is 90 degrees in the second case, the area of this sector will be 90 by 360 multiplied by pi r squared, which equals this. So if this angle is 30 degrees, then the area of the sector will be 30 by 360 multiplied by pi r squared. This part is the area of the circle, and this part tells us how much of the circle is covered. To generalize the formula for a sector, we can say that if the sector angle is theta, then the area of a sector will be theta by 360 multiplied by pi r squared. Look at the circle you see on the board. If we remove a part of the boundary, this is what we get. It's called an arc. The arc's length is basically a part of the circumference of the circle. How can we calculate the length of an arc? It's a curved length and cannot be measured with a scale. Let's understand a few examples. Cut
ಪ್ರಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಇಲ್ಲಿಗೆ ಇವತ್ತಿನ ವಿಡಿಯೋ ಇವುಗಳನ್ನು ನೋಡೋದ್ರ ಮುಖಾಂತರ ಯಾವುದೇ ಒಂದು ಘನಾಕೃತಿಯ ಮೇಲ್ಮೈ ವಿಸ್ತೀರ್ಣ ಇರ್ಬೋದು, ಪಾರ್ಶ್ವ ಮೇಲ್ಮೈ ವಿಸ್ತೀರ್ಣ ಇರ್ಬೋದು, ಅಥವಾ ಮುಂದೆ ಕಲಿತಕ್ಕಂಥ ಘನಫಲ ಇರ್ಬೋದು, ಇವುಗಳ ಸೂತ್ರಗಳನ್ನು ನಾವು ಬಿಡಿಸ್ತಕ್ಕಂಥ ವಿಧಾನವನ್ನು ಈ ವಿಡಿಯೋದ ಮುಖಾಂತರ ತಿಳ್ಕೊಂಡ್ವಿ. ಇದು ಇಂಗ್ಲೀಷ್ ಮೀಡಿಯಮಲ್ಲಿಂದ ಚಿತ್ರಗಳ ಮುಖಾಂತರ ಅರ್ಥ ಮಾಡ್ಕೊಂತ ಬರಬೇಕು. ಒಟ್ಟಾರೆ ನೀವು ಪ್ರತಿಯೊಂದು ಘನಾಕೃತಿಗೂ ಅದರ ಮೇಲ್ಮೈ ವಿಸ್ತೀರ್ಣ ಇರ್ಬೋದು, ಪಾರ್ಶ್ವ ಇರ್ಬೋದು, ಅಥವಾ